so this is our Honors Chemistry section 12.3 lesson video, and this is part 3. Yes, there is more. And so the last thing that we have to cover for our whole stoichiometry chapter is percent yield. So the theoretical yield is the maximum amount of product that can be formed from a given amount of reactants, and so it has to be calculated. The actual yield is the amount of product that is produced in the lab. So the whole thing about percent yield is it's kind of like your grade on the reaction. But when you have a grade in a class, you already know the highest is 100. And so then you're just trying to figure out what did you get out of 100. So if you get 73 out of 100, you got a 73%. But when it comes to reaction, we don't know how much you should have made. Should you have made 214 grams? Should you have made 187 liters? So we have to calculate how much we should have made, and then that way we can figure out what our percent yield is. So there is a formula. The percent yield is the ratio of the actual yield to the theoretical yield times 100. Oh, and apparently my line has disappeared. There should be a division line here. Okay, so you'll see me write it as our percent yield is our actual over theoretical times 100. Okay, so here, let me kind of separate this a little bit. So it's our actual over theoretical times 100. Now, since the theoretical yield is the maximum amount of product, the percent yield can never be over 100%. So this isn't like a grade in class where you can get bonus points. There's no bonus in a chemical reaction. So theoretical is the absolute maximum you can make, so your actual can never be bigger. It could be equal, but even getting 100% is not super common. So let's look at how you do one of these. So it says, what is the percent yield if 13.1 grams of calcium oxide is actually produced? Okay, now they're not always going to say the word actually in the question, but because this is a product, see how it's called percent yield? That's how much you're yielding. So your product will always be yielded. So it says it's actually produced when 24.8 grams of calcium carbonate is heated. So this is where some people get confused, because you see a number for this, you see a number for this, so then you're like, wait a minute, are you like going to CO2, or like what the heck's happening? Or worse, people just assume one of these is actual and one's theoretical, and they just try to go ahead and plug in. Okay? Neither of those are what's happening. What's happening is we did a reaction from here to here. We got 13.1 grams. What we need to figure out is our theoretical. How much should we have produced? And so that's where people lose track of what they're doing, because it's weird to go to the substance that you already have a number for. But remember, this is what actually happened. We're trying to figure out in a perfect world how much in theory we could have produced. So I start with what I know. So 24.8 grams of calcium carbonate. Step 1, of course, is to convert to moles. Yep, we're going back to our good old friend, the 3-step stoichiometry problem. Convert to moles. Since I have grams, I'm going to use molar mass. When you add up calcium carbonate, you should get about 100 grams per mole. So since grams is on top, I put my 100 grams on bottom and my 1 mole on top. Step 2, of course, is mole ratio using coefficients, and so I can see that 1 mole of calcium carbonate makes 1 mole of calcium oxide. So I follow my golden rule and I put the 1 mole of calcium carbonate on bottom, and that yields 1 mole of calcium oxide. So my calcium carbonate cancels out, and now I've officially switched over to calcium oxide. Step 3 is to convert to unit asked for. Now, it didn't technically ask me for a unit, but since it gave me grams, I would want to be able to compare it with grams. So I'm going to go to grams using molar mass, but this time I'm using the molar mass of calcium oxide. So when you add up calcium oxide, you get about 56 grams per mole. Since mole is on top, I put my 1 mole on bottom and my 56 grams on top. So my mole cancels. So now I got grams of calcium oxide, so I'm about to find out how much should be made in a perfect situation. All right, so once I multiply and divide, I get 13.9 grams of CaO. Now this is not the answer to the question. This is just the theoretical. It's asking what's the percent yield, so I'm going to have to use this formula. So see, now I have the actual, that's what they gave me. We just calculated the theoretical, so now I can plug into my actual over theoretical times 100. So percent yield is the actual over theoretical times 100. So my actual is 13.1 grams. That's what was actually made in the lab. In theory, they should have been able to make 13.9 grams in a perfect scenario. And then times 100 to make it a percentage. Your grams cancel. And so once you solve, you should get about 94.2. And then your unit for percent yield is, of course, the percent sign. So percent composition, percent yield, all of those have the percent sign. All right, so really the only new part, because we've done the 3-step stoichiometry problem a bunch at this point, so the only new part is having the actual, figuring out the theoretical, and then plugging into the formula. All right, so let's look at a couple more. Okay, so let's look at this one together, and then maybe you can try this bottom one. So it says if 50 grams of silicon dioxide is heated with an excess of carbon, 27.9 grams of silicon carbide is produced. What's the percent yield? Now, since it didn't say which one was the actual, sometimes people have trouble figuring it out. Well, remember, it's called percent yield, actual yield, theoretical yield. The arrow points to what is yielded. So that's how I know this has to be the actual and it can't be a reactant. A yield cannot be a reactant, it has to be a product. Okay, so I know this is my actual. I need to figure out what is the theoretical of SiC. So I'm going to go from here to here. And so like I said, that's the hardest thing that people struggle with on percent yield, is going to a substance where they already know a number. It just seems wrong. But that's what we have to do. All right, so I start with what I know, which is 50 grams of SiO2, and I follow my 3 steps. First step's convert to moles. Since I have grams, I'm going to use molar mass. When you add up SiO2, you should get about 60 grams per mole. So I'm going to put my 60 grams on bottom by following golden rule, so that grams cancel, and my 1 mole on top. Second step is, of course, mole ratio. So I can see that 1 mole of silicon dioxide equals 1 mole of silicon carbide. And so I'm going to follow my golden rule and put the 1 mole of SiO2 on bottom and the 1 mole of SiC on top. That way my silicon dioxide cancel. All right, and so then the last step is convert to unit ASCOR. Well, since they gave me grams, I obviously want to go to grams too. So I'm going to use molar mass again. But this time I'm going to use it for my SiC. So when you add that up, you should get about 40 grams per mole. So since mole is on top, I'm going to put my 1 mole on bottom and my 40 grams on top. So my mole cancel. So then I multiply across the top, divide by the bottom, and I end up getting about 33.3 grams of SiC. So see, this is my theoretical. So I should have made 33.3. I only made 27.9. So now I can plug into my formula. So percent yield equals actual over theoretical times 100. So my actual is 27.9. My theoretical is 33.3 times 100. The grams cancel. I'm running out of room. And I got about 83.8%. Alright, and so that's all you have to do. Like I said, for percent yield, it seems like the hardest thing is the setup, the initial setup. Like if you can figure out where you're starting and where you're going to, most people don't have a problem with it. Assuming you got the 3-step problem. Alright, so maybe pause it and you try this next one. I'll assume you've done that, and let's look at it together. So it says, when 15 grams of Sb2S3 reacts with an excess of iron, 9.84 grams of antimony is produced. What is the percent yield of the reaction? So again, I don't have to wonder, oh gosh, which one's the actual yield. A yield has to be a product. So this is my actual. I need to figure out what my theoretical is for SB. So I'm going from here to here. All right, so I start with what I know, which is 15 grams of my Sb2S3. So first step, hopefully you're kind of getting used to the steps. I I know I am in all these lesson videos. First step is to convert to moles, so I'm going to use molar mass since of course I was given grams. So when you add up SB2S3, you end up getting about 340 grams per mole. So I'm going to put grams on bottom so that I can follow my golden rule, my 1 mole on top. Second step, of course, is mole ratio using coefficients. So I can see that 1 mole of my SB2S3 yields 2 moles of SB, or antimony. So I'm going to put my 1 mole of SB2S3 on bottom because I'm going to follow my golden rule. And my 2 moles of SB on top. So my moles cancel, and now I've officially switched over to just SB, or just antimony. And so my last step is to convert to unit asked for. Well, again, since they gave me the actual in grams, I'll want to go to grams too. So I need to use molar mass again, but this time it's just molar mass of SB. All right, so molar mass of SB is about 122 grams per mole. So since mole's on top, I'll put my 1 mole on bottom and my 122 grams on top. So my moles cancel, and so once I solve, I end up getting 10.76 grams of antimony. So this is my theoretical. Remember, it's not my answer. My answer needs to be what's the percent yield. So then I just plug into my formula. So percent yield is the actual, which is 9.84 grams, over the theoretical, which we calculated we should have gotten 10.76 grams, times 100 to make it a percentage. Those grams cancel. And so when I solve, I got 91.45%. Okay, so like I said, really all we're doing is a basic stoichiometry problem to figure out theoretical, and then we're just using our percent yield formula, actual over theoretical times 100. Now we can ask to solve for actual, because of course unless you're actually in the lab, you won't know what the actual is. But if you know your percent yield, you can kind of work your way backwards and solve for what the actual was. Alright, so maybe pause the video, try this next one, or if you're feeling uncomfortable because of how long the question is, you can watch me do this one because there will probably be some more practice ones after this. So it says, adipic acid, which there's the formula, is used to produce nylon. Adipic acid is made by the following reaction. So here's my reaction. Assume that you carry out this reaction starting with 25 grams of cyclohexane and that cyclohexane is the limiting reagent. What is the theoretical yield of adipic acid? Alright, so on this one it's telling me I'm starting with 25 grams of cyclohexane. It tells me that cyclohexane is the limiting reagent. All that's telling me is I don't need to do a limiting reagents problem. It's telling me we have plenty of oxygen for the reaction to occur. All right, so it says, what is the theoretical yield of the adipic acid? So in other words, we're looking for our theoretical yield for this. So I'll just put question mark T. Okay. Now I can see that there's a part B, so I'll go ahead and tell you in part B, well here I'll just show you. It says, if you obtain 33.5 grams of adipic acid. So see, now I also know that my theoretical should be in grams. Okay, so in other words, we're just going from here. Oh, I have my answer up here. Don't look at that. All right, so I'm going from here to here. And notice it didn't ask me for percent yield yet. It's going to ask me that in part B. It's just asking me to calculate, in theory, how much adipic acid should I make. Alright, so I start with my 25 grams of cyclohexane, which is C6H12. So of course step 1 is convert to moles. Since I have grams, I'm going to use molar mass. So when you add up C6H12, you should get about 84 grams per mole. So since grams is on top, I'm going to put my 84 grams on bottom and my 1 mole on top. So my grams cancel. Next step, I have mole ratio. So I can see that 2 moles of my C6H12 yields 2 moles of my adipic acid. But because I have the cyclohexane on top, I'm going to put the 2 moles of cyclohexane on bottom and the 2 moles of adipic acid on top. Oh gosh, okay. We're getting kind of long formulas here. Whoops. long formulas here. All right, and then last step, of course, my moles cancel. I have officially switched over to adipic acid. My last step is to convert to unit mass force. So since they gave me the actual in part B in grams, I'm going to go to grams also so that I can compare the two. All right, so if we're going to convert to grams, we're going to use molar mass, but this time it's for adipic acid. So when you add up this formula, the molar mass on the periodic table, you should get about 146 grams per mole. So I'm going to put my mole on bottom. So 1 mole of my adipic acid. Oh, when you have a long formula, it gets annoying writing it. And that is 146 grams. All right, so my moles cancel, and so then I just multiply across the top, divide across the bottom, and so I ended up getting about 43.5 grams of my adipic acid. Okay, and so this is my theoretical. Okay, so I can see that I got 43.5 grams of adipic acid, starting with my 25 grams of cyclohexane. Okay, now again, this is my theoretical. This is what we should get. On the next part, they're going to tell us what we actually did get. So I'm going to leave this down here, though. So then it says, if you obtain 33.5 grams of adipic acid from your reaction, what is the percent yield? Okay, so in other words, what they did now was now they gave you the actual. Okay, well, I already did the hard part. The hard part is getting the theoretical. So now I just need to plug into my formula. Percent yield is actual over theoretical times 100. So percent yield is my actual, which is 33.5 grams, divided by my theoretical, which is 43.5 grams, times 100 to make it a percentage. The grams cancel, and so once I solved, I ended up getting about 77%. So we made about 77% of what we should have. All right, so let's look at another one. If you haven't been trying on your own, definitely try this next one. All right. So the next one, we have a part A and part B again, so maybe pause it, try these, and then we'll look at them together. So it says, if you start with 150 grams of Fe2O3 as the limiting reagent, so again, that just means I don't need to worry about figuring out if it's limiting or not. What is the theoretical yield of iron, or Fe? Now I can go ahead and look at part B and see that they're going to give me the actual in grams. So that means for my theoretical, I want to also switch to grams. So I'm going to go from here to here to figure out my theoretical. And then, because they're going to give me the actual in part B, I can then calculate the percent yield. So we're going to start with our 150 grams of Fe2O3. And so step 1, hopefully you have this burned in your mind at this point. Step 1 is convert to moles. Since I have grams, I'm going to use molar mass. So Fe2O3, when you add that up off the periodic table, you're going to get about 160 grams per mole. So since I have grams on top, I'm going to put my 160 grams on bottom and my 1 mole on top. So my grams cancel. Next step, of course, is mole ratio, using some coefficients here. So I can see that 1 mole of my Fe2O3 yields 2 moles of my iron. I'm going to put the mole of Fe2O3 on bottom because, of course, I'm following golden rule. And that yields 2 moles of iron. So see, now I have officially switched over to iron. And now I just need to finish up. So it says convert to unit ASPOR. Well, I'm trying to get to grams. So again, I'm going to use molar mass. And so the molar mass of iron is about 56 grams. So I'm going to put my 1 mole on bottom because I want to follow the golden rule. And that equals 56 grams of iron. So I multiply across the top, divide across the bottom, and so I ended up getting, let's see, where is what I got? Oh, there it is, okay. Looks like 105 grams of iron. So this is my theoretical. Okay, so in theory, if I react 150 grams of Fe2O3 with excess carbon monoxide, I should get 105 grams of iron. However, part B tells us that we actually ended up getting 87.9 grams of iron. So what is the percent yield? Well, again, I already did the hard part. I figured out theoretical. They gave me actual, so I just plug into my formula. Actual over theoretical times 100. So percent yield is the actual, which is 87.9 grams, over the theoretical, which is 105 grams, times 100. The grams cancel, and so I ended up getting about, oh, I almost looked at the wrong answer, 83.7%. All right, so hopefully you got that one right. All right, so let's move on and look at kind of just a combo of everything we've learned for this chapter. Like if you can do this next problem, you're just super awesome. Because it's just a combination of literally everything. All right, so it says if 15 grams of nitrogen reacts with 15 grams of hydrogen, 10.5 grams of ammonia is produced. What is the percent yield? And I gave you a hint. This is a limiting reagent and a percent yield problem. Okay, so if you dare, pause the video and try this on your own. If you can get this one, you literally have stoichiometry down. Okay, so I'm going to assume you paused it and you tried it. I'm going to assume you struggled so long, but you got it right, and so let's see. So it says if 15 grams of nitrogen reacts with 15 grams of hydrogen, 10.5 grams of ammonia is produced. What is the percent yield? So this one should throw you off because it's like, wait a minute, I know the numbers for everything, but I know because this is a product and this is a percent yield problem, this is my actual. So I know I need to figure out what the theoretical for this is. But they gave me 2 starting amounts. That's why it's also limiting reagent. So I'm going to have to go from nitrogen to our product, get an answer. Go from hydrogen to our product, get an answer. The lower of those will then become my theoretical. Then I can plug in actual over theoretical times 100. See, isn't this like the best stuff ever? All right, so let's go ahead and get started. So we're starting with 15 grams of nitrogen. So the first thing I'm going to do is figure out how much ammonia I need to produce if all 15 grams of nitrogen reacts. Okay, so step 1 is convert to moles. Since I have grams, I'm going to use molar mass. N2, of course, has a molar mass of 28 grams per mole. So I'm going to put the 28 grams on bottom because I'm following my golden rule as always, and my 1 mole on top. Step 2 is mole ratio. So I can see that 1 mole of nitrogen will yield 2 moles of NH3. So since I'm following my golden rule, I put my 1 mole of nitrogen on bottom, my 2 moles of NH3 on top. So that cancels, so I officially switched over to NH3. Last step, convert to unit Ascor. Well, since my actual is in grams, I want to get to grams also, so I'm going to use molar mass again, but this time I'm using it for NH3. So NH3 has a molar mass of 17 grams per mole. So since mole is on top, I'm going to put my 1 mole on bottom and my 17 grams on top. So my moles cancel, and so when I solve for this one, I end up getting 18.21 grams of NH3. Now see, this is where it's different than a normal percent yield problem because I have no idea if this is my theoretical yield yet because I have to see what would happen if hydrogen is the limiting reagent instead. All right, so I'm just going to kind of keep that right there, and I'm going to move on and start with hydrogen this time. So I have 15 grams of hydrogen, which is H2. My first step is convert to moles. Since they gave me grams, I'm going to use molar mass. So H2, of course, is 2 grams per mole. Since grams is on top, I'm going to put my 2 grams on bottom and my 1 mole on top. So grams cancel. All right, next step is mole ratio using coefficients. So I can see that 3 moles of hydrogen yields 2 moles of ammonia, or NH3. Since hydrogen's on top, I'll put my 3 moles of hydrogen on bottom, my 2 moles of ammonia on top. So my moles cancel. I've officially switched over to NH3, which is good. All right, last step is convert to unit Ascor. Well, again, since actual is in grams, I want grams too, so I need to use molar mass. But remember what I told you on limiting reagents problems. We just did grams of NH3, so I can bring that step down. So 1 mole of NH3 is 17 grams. So then I just multiply and divide, and so when I do that, I got 85 grams. dealing with a limiting reagent, limiting makes the lower amount. So that means my theoretical will be the 18.21, okay, because we're not going to have enough nitrogen to make the 85 grams. So see, now I have my actual, now I have my theoretical, so now I plug into my formula. So remember, percent yield is actual over theoretical times 100. So my actual is 10.5 grams. My theoretical, whoops, sorry, I'm pointing the wrong one. My theoretical is 18.21 grams times 100 to make it a percentage. And so once I solve, I get about 57.7%. All right, so like I said, the reason I say this is kind of everything combined in one, it's because we use mole ratio. That's the first thing we learned. We used the three-step problem. That's the second thing we learned. We did limiting reagent where we picked the lower. That was the third thing we learned. And then we did percent yield where we do actual over theoretical times 100. That was the fourth thing we learned. Surprisingly, in all these hours and hours of lesson videos, we actually only learned 4 things. All right, so let's move on because we deserve to finish up the section assessment. All right, so section assessment. Thankfully, there are only 2 questions. My gosh. All right, in a chemical reaction, how does an insufficient quantity of a reactant affect the amount of product formed? Well, remember, an insufficient quantity implies it's the limiting reagent. The limiting reagent determines the amount of product produced. So once the limiting reagent is out, like once it runs out, you can't make any more product. So that insufficient quantity, that limiting reagent, is what determines how much product you will produce. All right, so last one. It says, what is the percent yield if 4.65 grams of copper is produced when 1.87 grams of aluminum reacts with excess copper 2 sulfate? So see how it says with excess copper 2 sulfate? That's just letting you know this is not a limiting reagents problem. It's telling you copper 2 sulfate is the excess. So I need to go, I know this is my actual because remember actual has to be a yield or a product. So I need to figure out, well, what is my theoretical so I can get to my percent yield. And see, since it didn't give me 2 starting amounts, it's not limiting reagent. All right, so I'm starting with what I know, and that's that I have 1.87 grams of aluminum. Oh, so back to our favorite 3-step problem. First step is to convert to moles. I have grams, as seems to be the only thing I gave you in all of this section, so I'm going to use molar mass. So molar mass of aluminum is about 27 grams per mole. So since grams is on top, I'm going to put my 27 grams on bottom and my 1 mole on top. So my grams cancel. Step 2 is mole ratio using coefficients. So I can see that 2 moles of aluminum yields 3 moles of copper. So I'm going to put my aluminum on bottom because I'm following my golden rule, and my 3 moles of copper on top. So see, now I've officially switched over to copper, so aluminum's gone. Step 3, convert T to ascor. Well, since my actual was given to me in grams, I want my theoretical in grams. So I'm going to use molar mass, but this time I'm using the molar mass for copper because aluminum's gone and now I'm down to copper. So copper has a molar mass of about 64 grams per mole. So I'm going to follow my golden rule and put mole on bottom and my 64 grams of copper on top. So my moles cancel. So I'm ready to solve. Multiply top, divide bottom. I get 6.65 grams of copper. So this right here is my theoretical. So see, now I have my actual, I have my theoretical. Oh my gosh, we're almost done with this lesson video. I'm not going to lie, if you hadn't noticed, I've been wearing the same clothes. So I've made a lot in one day. I'm very tired. All right, so percent yield is actual over theoretical times 100. So my actual is 4.65 grams. My theoretical is 6.65 grams times 100. Those grams cancel, and so once I solve, I get about 69.9%. All right, so for stoichiometry, like I said just a minute ago, there are 4 main concepts you have to get. You have to be able to do a mole ratio. You have to be able to follow the 3 steps and know when to leave steps out. You have to be able to understand limiting reagent problems, whether it's telling me what's limiting, what's excess, whether it's telling me how much product's formed, or whether it's telling me how much excess remains. And you have to be able to do percent yield. So see, it's really not that bad. Practice, 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 because the faster you get at them, the less daunting they seem. But you got this.